Hello everyone, my name is Chirag Patil and welcome back to my YouTube channel. So in today's video, we will understand how RAG, Retrieval Augmented Generation, works using LLM, and we will implement it using LangChain and Hugging Face, right? So basically let's understand what is RAG, right? So in RAG, which stands for Retrieval Augmented Generation, we allows the LLM to understand our dataset and reply accordingly, right? So let's take an example. If you use ChatGPT, right? So it is trained on larger data set and it can provide an answer of general questions, right? Let's say, uh, what is mango or any general questions, right? But if you want to reply using your own knowledge, right? Let's say you have some website of your product, right? So you need to provide the answer using ChatGPT using your website dataset, right? Okay, and let's say there is you have number of PDFs in which your data is stored and you need to provide users answer based on that number of PDFs, right? So in this case we use RAG, right? So let's understand the flow of RAG and then we will implement, right? Okay, so let's understand using this diagram. So this diagram is taken from the Hugging Face site, right? Okay, so let's understand. First of all, we have our knowledge base, right? So knowledge can be anything. Let's say number of PDFs are there, or you can have text files, right? Or you can have web pages, right? This can be your knowledge. Okay, so first of all, what we will do, we will divide our PDFs, text or web page, whatever we have in the knowledge form, right? So we will divide into smaller parts, right? Which will called as a chunking, right? So we will understand why chunking is required, right? So just understand, currently we are dividing our document into smaller parts, right? Okay, so next step, after dividing into smaller part, we will use embeddings, right? So embeddings is basically, you can say, a numerical vector of our text which will represent the meaning of text, right? So for example, if there are two words, let's say one word is happy and the second word is sad, right? So if you convert that both word into the embedding, you will get some, let's say, numerical array, right? Let's say some array, let's say 0 0.1, 0 0.2 and 4, this kind of value, right? And for other word, let's say this is for happy word, right? And this is for sad word. You get similar, let's say 1, 0 0.09 or something like. So when you convert a word or text into embeddings, you will get a numerical vector, or you can say numerical array, which consists a semantic meaning of particular words, right? So if you take a similarity of these two vectors, right? Let's say cosine similarity, then we will get very less similarity between these two words, right? So this is called as a semantic embeddings, you can say, which contains semantic meaning of words. Okay, so second step is we will convert it into embedding, right? And for all our chunk, or let's say all parts of our PDF, text or web page, whatever we are using, we will create a one database which we'll call as a vector database, right? Which is a vector database. Okay, so now we have our knowledge base into a vector database, right? So let's say now if any user arrives and he asks something, right? So let's say user is asking about your product. Let's say what does it means related to your any product, if you have knowledge base about the product, right? So what you will do, there will be a user query, right? Let me rewrite. There will be a user query, right? So using this user query, we will find similar vectors, which is basically a text, right, in the numeric form. So we will find top k similar points, right, which are very similar to user query, and we will get the text of that embedding, right? So let's say we receive our k is equal to 5 and we receive 5 vectors which are very similar or very near to user query, or which is related to user query, right? So if you see, if I get 5 vector and according to the text of related to 5 vectors, right? So we can use that information and provide that information to LLM as a context, right? And we will write our prompt like you have to provide the answer based on a given context, right? So based on that prompt, LLM use our context, user query, and it will generate answer, right? Which will be our answer. Okay, so let's understand and implement it using LangChain and Python, right? I hope this flow is clear. If you have any doubt, you can write in the comment section. We can discuss there as well. Okay. So now let's do code. Okay. So there are a bunch of library I has already imported, right? So there is first is LangChain and LangChain community, and there is unstructured, which will be used to get load unstructured data set like let's say web page or PDF, anything, right? There is sentence transformer, which we will use to create embeddings of our chunk, right? And this is Faiss, which is like Facebook a similarity search. It will contain our vectors, or you can say this will be our vector database. We will generate a vector using sentence transformer and save it using Faiss. Then Hugging Face, then LangChain Hugging Face, and accelerate and bits bytes. So bits and bytes is basically used to load quantized version of model, right? As we are using in the Colab, and you if you want to use less memory, then you will load mobile model into quantized form. Let's say 4-bit or 8-bit, right? Okay. Then accelerate will use for accelerating our performance. It will be used by bits and byte. Okay. So these are few library. Let's import, right? Okay. So first of all, let's understand what we are doing in this tutorial, right? So I am taking one web page, basically a Wikipedia web page, okay, and we will use this as our knowledge, okay. So these are the text. Let's say we need to answer using this page, right? So you can see there is a lot of information is here, right? So we will use this web page and convert it into a vector database, and then our LLM will be provide answer based on this information, right? Let's start. So first, let's say we need to create a vector database, right? So let's say create vector DB. Okay. So what we will require? So let's say I will consider URLs, right? So okay, basically in this tutorial we will use web page URLs. Okay. You can also implement using PDF and text file as well. So let's say web page URLs, right? And let's say we need vector DB path. Okay. So now we need one loader which can load our URL, right? So there is a function in LangChain which is unstructured URL, right? So it would be like from the unstructured point of view, I think. Okay. Okay, so LangChain document loader, we had imported unstructured loader, right? So let's use it. So basically this unstructured library is used by this LangChain package. Okay. So now here we need to pass a web page URLs, right? So let's say web page URLs, okay. And now data will be loader.load data, right? Okay. So now what we are doing, if we get any web page here, basically we will pass a list of web page. In our case, it will be only one, right? So it will load all of the content of this and convert it into text format, right? Basically it is the HTML form, right? Okay. So now we need to convert this all data point, or you can say all web page, into a chunk, right? So let's say text splitter is equal to, we will use recursive text splitter, right? This one. I'll explain what it is doing, right? So it will require, let's say, chunk size, right? Chunk size is equal to, let's say I will apply 1000. Okay. So let's first understand what this recursive character text splitter do, right? So there is one page which is basically explaining how it is working, right? So basically, let's say I have this text as my data, okay, and I need to convert it into chunks. So there are two methods in the LangChain. Basically, there is a character splitter and another is recursive character splitter, right? So first of all, let's understand character splitter. So let's say my chunk size is equal to 25 and chunk overlap is equal to 2. So what does it method will do? It will convert our data set, or let's say this text file, into 25 character chunks, right? Into 25 character chunks, okay? And chunk overlap is equal to 2. That means the next chunk will contain the 2 character of previous chunk as well, right? So if you visualize here, let's say this is my first chunk, right? This one of the most important, till important, okay? So now from important we are creating next chunk, right? Which is things I didn't understand, right? So if you see that last 2 character of first chunk in this blue point, right, nt, are also part of this second chunk as well, right? So if you see here, this is my first chunk right here, and from this till here I have my second chunk, right? So if you see here, we are using chunk size some static number, right? So it is not always convert our uh, text into proper chunk. Like if you see here, my text is splitted, right? Like we are not chunking into one sentence here. So basically if you see this, we can create chunk like this one would be first chunk, this can be second chunk, right? So if I improve here 250, then also this character splitter will also work on the chunk size, right? So it will not consider anything, it will just calculate the 250 character and split one. Okay, so this is character splitter, and there is another method which is recursive character splitter, which we will use, right? So if you see in recursive character splitter, it will use some predefined a separator. So right, let's say slash n slash double n, right? New line character, double new line character, comma. Okay, so first it will check double slash n, right? So if it will find double slash n, or say double new line character, then it will divide at that point, right? So let's say if you see here in this scheme with recursive character text splitter, we are getting a proper chunks, right? Here you can see some words can be skipped, but you can see here my words are not splitting. Let's say half as we are getting proper words already, right? But here there is no overlap, or chunk overlap is not there, right, in this method. Okay, so if you use proper chunk size, it can be work very well, right? Okay, so this is a recursive text splitter we will use, right? Okay, so let's say docs is equal to text splitter dot split documents, right? And this will be your data. So we had created the object of recursive character text splitter, and chunk size is 1000, and we are now splitting our document, right? Okay, so now we need to do embeddings, right, of these chunks. So if you see the docs, right? Okay, so let's understand what are the in each value, right? Then we will create a function. Okay, so yeah, okay, so for web page URL, we will use this URL, right? So let me define URLs is equal to, we are only using one URL for learning purpose. Okay, so let's say URL will pass here. Okay, so now let's see how this splitting works. It will take a few seconds. Let's see. Okay, so let's see first data. Okay, so here you can see we got all the text of that page, right? Yeah, here if you see page content is everything which is on the that web page, right? We don't get here any HTML text, but we get all the text here, right? Okay, so this is basically our data which had loaded our URL. Okay, so now let's see what is the docs, right? Let me clear this output. Okay. Okay, so if you see the docs, it will contain a chunks of 1000 characters. Okay, so let's say docs of 0. Okay, so this contains this much information, right? Which is basically 1000 character, I would say, or nearest breaking point or separator character which we found, right? So this is the second doc. So basically in data we have all the detail of web page, all the content of web page. In the docs we have splitted data, right? Okay, so let me delete this and let's create embeddings, right? So let's say embedding function. So we will use sentence transformer here. So LangChain also provides sentence transformer embeddings, right? So basically, let me write and then I will explain. Okay, and we need to pass a model name here. Okay, so in sentence transformer there is a library in Python which called sentence transformers, and they are provide this much models, right? These all are the models, they are supported by sentence transformer. So in here we can use any model here, right? So but we will gonna use this all MPNet base v2. Okay, so let's copy this and pass it here. Okay, so basically we had created our embedding function. We will pass a text into this and it will generate embeddings. Okay, so now let's create a database. Let's say vector store is equal to, we will use Facebook AI similarity search, right? And it contains one method, let's say from document, right? So there is a suggestion from documents and we need to pass a documents which is we had created here, right? Docs. So docs comma we need embedding function here. Okay, okay, so what this FAISS from document will do, it will take what is the embedding function. Okay, the typo here. Okay, so the now embedding function. Okay, so now what this from documents will do, it will take each document from this, and using this function you can pass any model, right? We are using sentence transformer, but you can use OpenAI model as well and any other Hugging Face model as well. So it will take this model and convert this each document into embeddings, right? And it will be stored in the vector store, right? So let's write this vector store into the file so we can reuse it anytime. Okay, so we can store it into a pickle file. Okay, so let's say with open, so we are taking this an argument vector db path, so we will use that argument vector db wb as f pickle.dump. Alright, simple read write operation of the pickle file will help here. Pickle.dump vector store. Okay, and pass the f. Okay, yeah, so this function will create a vector database for our web page URLs. Okay, so let's run this. Okay, so let's say we are passing URLs. For this tutorial we are using only one URL page, right? You can pass as many as you can. And then let's say vector db path, I would say let's create one directory, right? Let's say mkdir data. Okay, so we created one data directory and we'll just pass data slash, let's say embeddings dot pickle. Okay, so let's create a vector db. Okay, so there are few warnings. It will take few seconds, right? It will also download this model as well, which is all MPNet base v2, right, for from sentence transformer. Okay, okay, so model is downloaded. Okay, so we are get all the embeddings for our documents, right? Okay, so now let's use LLM, right? So basically in the flow we understood that after creating one embedding we will find the similar documents from the vector database and we will pass it as a context to the LLM, right? So we would require one LLM, right? So for LLM I am using this function. Basically I am just borrowing the code from here which will use the LLM and load the LLM using bits and byte config using 4 bit, right? So it will use less memory. So let's just copy this code, right? Okay, so here if you see we are just creating a model and tokenizer and generating a Hugging Face pipeline here, right? And we will use Zephyr 7b beta large language model, right? So let's run this. It will also take few seconds. It will also download the model, right? Okay, so the model is loading. Let's write the code to our prediction pipeline, I would say, or let's say inference, right? Let's okay, so first of all we need to load our vector database, right, which we had said. Let's say with open. Currently it's already open, so let's just we can say we are rereading it. Okay, so let's say what was our path of vector db? It is data, right? Data slash embedding dot pickle. Okay, and we need to read it into binary mode, right? As if let's say vector store is equal to pickle dot load f, right? Simple, like read that operation of pickle files. Okay, so we can we'll check once this model is loaded, we'll check that as well, like how this FAISS work, right? Okay, it's downloading. It's quite larger files, so it will take time. Okay, let's write one line as well to check. Let's say vector store dot there is a function which is a similarity search, right, with any database. If you see the ChromaDB or FAISS or anything, you will find this similarity search method in that, right? So similarity search, and you need to pass a query which can be anything, like any questions or any whatever you need the information, right? So let's say I will pass any question from here. Let's say let's read this and just create one question from here, right? So let's say it's India is officially Republic of India, country in South Asia. So let's ask the simple question, what is India, right? Okay, what is India? So let's it, still it will take few times to download, right? Okay, loading the checkpoints. say this. Okay, so let's understand these parameters, right, while the model is loading. So if you see here, one parameter is temperature, right? So temperature will allow LLM, any LLM, to generate a text in more creative way, right? So if you increase the temperature, let's say you are passing zero point 0.8 or zero point 0.9, so output would be more differ when you are rerunning the same questions, right? So basically it will generate a more creative answer and add their own information by it own. Like if you not provide any context, let's say context are very small, but it will create their own answer in more creative way, right? So whenever you need a crisp and clear answer, it is advisable to use temperature argument lower, right? Generally people use 0.01 and 0.1 zero point 0.2, maximum 0.5, except you want a more creative answer, right? Okay, so this was about the temperature. Okay, so let's okay, so model is loaded. So now let's understand what the vector store is, right? So we are just opening, or we can say we are loading our vector database, and let's say similarity search. It will use like second argument, which is k. K is basically how many documents you need which are very similar to our query, right? So let's say similar docs. So I'm just I'm just passing k is equal to 1 to get first document which are most similar to our query, right? So just to check similar docs. Okay. So if you see here in the documents, there is a key which is page content, which contains our documents, or you can see a particular chunk which we had made using recursive character text splitter, right? And which is very similar. So as you know, it also contains the answer, right? India is officially Republic of India in the South Asia. What we are reading here, right? This is the basically the same part, you can say, which is we have a chunk. So what we can do, we will pass this information with this query and tell the LLM to generate answer using this information, right? This is basically what RAG does, right? So let's implement that particular code. So we have our own vector database. Another thing, we have our own LLM, which is also open source, right? So let's write the code. Let's get answer from LLM, right? Simple. So what we will require? We will require one query, which will be basically a question of the user, right? So let's say we need to find similar docs, right? So we can use same this line here as well, right? Similar docs. We are just using k is equal to 1, and here we will pass our query, right? Okay. So now we need to pass context. So sometimes it happens if you ask some irrelevant, so maybe there is not much similar documents, right? Or it can be written also or none as well sometimes. So let's write in that way, similar docs of 0 dot page contents, right? This key. Let's say page content if similar docs. If we receive any similar docs, right? Else it would be empty string, right? So now we need to write one prompt for the LLM, right? So let's say prompt. So basically in prompt we will define that you need to provide answer only from the given context, right? Otherwise it will provide the answer of any question, but we don't want that, because we only want our bot to answer related to our only our product, right? Or any knowledge base which we are providing, right? Otherwise we can use any general purpose LLM, right? So let's say we write okay, let's write app string, and we can define our prompt like, let me write like you are an AI assistant, okay, assistant, and please provide answer to the following question. Following question using only the information provided in the given context below, right? In the context below. Okay, and let's say if there is no relevant, sometimes it's happened like if you are asking any questions which is irrelevant but we found some similar docs, right? So LLM needs to understand that the query and context are not matching properly, so it should avoid to provide the answer based on that, right? So we are writing here, if there is no relevant information in context, right, to answer the question, respond with, let's say only one sentence, right? Only one sentence which is let's say I don't know, right? We can write anything. Let's say if you are any help desk kind of setup, then you can say you can write our email to this particular email ID, right? But for this example we are passing only I don't know, right? Let's say I don't know. Okay, and let's give the information like do not include your additional information, right? So let's say do not provide any additional information. Sometimes like LLM use our context and also provide some extra information, right? So we don't want that here. Information or make any assumptions beyond what is included in context, right? Because if you see the LLMs are already trained on a larger amount of data set, right? So it might be the case that LLM can understand the question but it is not relevant in the context, so we should avoid that kind of scenario because LLM can generate any kind of answer, right? So we are restricting our LLM to generate answer by its own without understanding the context, right? So let's say context can be context, right, which will be this context, right? And let's say user query. Okay, so user query is this. Okay, and let's pass, let's say response need to generate it, right? Okay, so this will be our prompt, right? And now let's apply this prompt to the LLM and LLM will generate the answer, right? So let's say return LLM prompt, right? So we need to just pass the prompt here and it will generate the answer, right? So let's run this and let's ask the same question, right? Let me copy this. We'll pass the same question like what is India. So here the LLM, okay, so prompt is typo there, and okay, so it is reader LLM, right, not the LLM. We had get the code from that Hugging Face page, right? Okay, so prompt is same, reader LLM is there. Okay, so now let's rerun. Okay, so let's see what we are getting as a context is not defined. Okay, so again there is one spelling mistake. Okay, let's run. Okay, it will take few seconds to generate the answer, right? Because we are running it on a local system, so it will take time. Okay, so generated text is India is the country located in the South Asia. It is the 7th largest country, right? So we are getting the correct information, right? Here you can pre-process it like you need to just, let's say, taking the first answer of the list, right? It is returning a list. Okay, so let's rerun and let's ask some other question by seeing this web page, right? So let's see here. Okay, so modern human arrived on the India from Africa. Okay, it has been since 95. Okay, so what is the question we can ask, right? Okay, so here is the like the first modern human, Homo sapiens, had arrived Indian subcontinent Africa. Okay. Hmm. Okay. You can ask any question, but let me form one question from using this web page, right? So let's ask like how India name arrived, right? Maybe they have written somewhere. Let's ask. So let's say how name India arrived, right? Okay, so it's disconnected. Let me reconnect. Unable to connect the runtime. Okay, so now it's reconnected. Let's run this code, right? Like how name India arrived. Okay. Okay. Sim pipeline sequential and GPU in order to maximize efficiency. Please use dataset. Okay. Let's ignore it currently. Okay. Okay, so we got the answer. The name India originated from classical Latin. Okay, so let's see in that web page whether it was mentioned. We were finding, right, like yes, here. So according to Oxford English Dictionary, the name India derived from the classical Latin India, right? So we are getting the same answer right here. So it is a very good implementation, we can say, or it is working as expected, right? So this is all about the RAG or retrieval augmented generation. We had used here Hugging Face and LangChain and sentence transformer for vector converting a text into the vector, right? So all the models are open source. You can use your OpenAI embeddings and OpenAI model as well, right? So this is all about RAG. So if you have any question, you can ask in the comment section. We can discuss there. And if you like my video, please press the like button and share it with your friends and subscribe my YouTube channels. We will meet in the next video. Thank you.